2.2, we're going to learn about characteristics of quadratic functions. So it says recall that a vertex from a quadratic function, our vertex form is this. A vertex of a quadratic function is the point on the graph at like the either very lowest or the very highest. So the vertex is that point. And that point is h comma k. If our quadratic function is in vertex form, so if it's in this form here, we just need to see what's being added inside the parentheses and what's being added outside the parentheses, and that gives us the point hk. So that gives us the vertex. All we have to do is look at our vertex form, and we can identify the vertex. And notice here how it's a minus h, so we change the sign of h. All right, so we can write something that's in standard form. So if we look here, we've identified our vertex, or we've identified our zeros from standard form. But it's easier to identify the vertex once it's in vertex form. The notes are a little bit backwards here, so it'll get to it in a little bit. But for our vertex, we use the formula negative b over 2a. There we go, that color is better. So negative b over 2a helps us find the h. And then to find the k in our vertex, we plug that negative b over 2a into x and solve. So these are two important things that we need to know here. So just like before when we were doing quadratic formula and stuff, our a, b, and c comes from the coefficients. So a would be 1, b is negative 12, and c is 18. So when I plug this into my formula, negative b over 2a, it would be negative 12 over 2 times 1. And then we can simplify this to positive 12 over 2, which is 6. So 6 is my h. That's what I found first. That is the x coordinate in my vertex. 6. Now to find the y, we take 6 and plug it into all the x's in my equation and solve for y. So this would be 6 squared minus 12 times 6 plus 18. So 36 minus, what's 12 times 6? 72 plus 18. So then we just add them all together, negative 36 plus 18, which would be negative 18. So the y-coordinate, or my k, is negative 18. So this is my vertex. And then the last step is we're going to put it into vertex form, which is my equation up here. So my vertex form would be y equals, what's my a? One, so it'd be 1 times, do I need to write the 1 if I'm multiplying it? No. But if it was any other number besides 1, we would write it out front. And then x minus, what's my h? 6 squared plus, what's my k? negative 18, so it'd actually be minus 18. So that is my equation in vertex form, and that would be my vertex. So notice how in vertex form it is a x minus 6, even though it's a positive 6 for my vertex, because you always change the sign of the h. So let's take a look at 13. So I need to first identify my vertex, and then I can just plug it into my vertex form. So to find the h in my vertex, that formula is negative b over 2a. What's my a? 1. What's my b? And what's c? 18. Perfect. So let's plug it in. So this would be negative 8 over 2 times 1. What's negative 8? Positive 8 over 2 times 1, which is just 2. So this would be what? 4. So my h in my vertex, my first one would be 4. So that's h. Now how can I find k? Plug it into all the x's. So I'm going to plug it into the x and the x in my original equation. So I'm plugging 4 in. So that would be 4 squared minus 8 times 4 plus 18. When you plug it in, make sure you follow your order of operations. So first I would have to do 4 squared, which is 16, minus, what's 8 times 4? 32, plus 18. So 16 minus 32 would be, and negative 16 plus 18, positive 2. So my k is positive 2. So then the last step is to plug it into our vertex form. So it starts with y is equal to, what's a? 1. So we don't need to write it when a is 1. Times x minus h. What's my h? 4. So x minus 4 squared. Plus k. What's my k? 2. So that's my vertex form, and this is my vertex. So these are the two answers. So as I mentioned in the first slide, our vertex is either the very lowest point of the graph or the very highest, depending on which way our parabola opens. It could be a smiley face like this. So our parabola would be the lowest point, or it could be a frowny face like this. And our vertex would be the highest point. So it's always like that peak of the graph. And our vertex is h comma k. But we also have this thing called the axis of symmetry. So the axis of symmetry is a line that divides the parabola into mirror images and passes through the vertex. So our parabola is the equation of a line, which is just x is equal to h. So because it's the x value, we just use whatever our h value is and repeat it in our axis of symmetry graph, our axis of symmetry line. So the axis of symmetry just cuts the parabola right down the middle. It goes through the vertex. So whatever our h value is in our vertex, that first number is the same number in our axis of symmetry. Yeah, so our axis of symmetry always cuts through the middle, whether it opens up or opens down. And then whatever we have on the left side of the graph, it's the same thing that's going to happen on the right side too. All right, so example 1 says using symmetry to graph quadratic functions. So it asks us to graph and label the vertex and axis of symmetry. So I'm going to draw my graph here. The first thing we want to find for our graph is the vertex, and then we can easily identify our axis of symmetry. So this graph is already in vertex form, so I can clearly identify what my vertex is. What is my vertex? Perfect. It comes from what we're adding inside and what we're adding outside, but we always have to change the sign of h. So it would be negative 3, 4. Yes.
In the homework, this question
Right. So we always change the sign of h. We didn't do any work. You just look at your vertex form, and all you have to do is identify the two numbers. Perfect. So next, let's write our axis of symmetry. So it's always x equals because it's a line, and we just repeat the x in the vertex. So x equals -3. So once we have our vertex and our axis of symmetry, we're going to plot those two first. So my vertex is -3, 4. So I go to the left to -3 and up 4 and put a point right there. Then my axis of symmetry is a vertical line that just goes right through it. Right, so I only have 1 point on my graph. I have to figure out a couple more points just so I know what direction it's going in and what it looks like. So to find more points, we want to plug in values for x. So I'm going to write that down because it's important. To find more points, we plug in numbers for x. We always want to plug in something close to the axis of symmetry, because the further away that we get from the axis of symmetry, the bigger our numbers will end up being, and it's just going to be more work for us. So what's an x value that's close to the axis of symmetry? What's an x value that's close to -3? -2, perfect. So let's plug in -2. So y is equal to -2 times -2, because I'm plugging that in for the x, plus 3 squared plus 4. Make sure you follow your order of operations when solving. What do I have to do first? PEMDAS. What's the P stand for? Parentheses. So -2 plus 3 would be 1. What's the E stand for in PEMDAS? Exponent. 1 squared is still just 1. What's the M stand for in PEMDAS? Multiply. So then I multiply. So -2 times 1 would be -2. And -2 plus 4? 2. So I plugged in -2 for x, and I got 2 for y. So this is another point on my graph. This is what you plugged in. This is what you got. So let's plot that point. I'm going to go to the left to -2 and up 2. So it's right there. So now we could keep plugging in numbers and getting more points on our graph, but we know that our axis of symmetry is a mirror. Whatever we have on the right side, we also have on the left side. So if I have a point that's 1 space away from my axis of symmetry right there, I'm going to have the same point, that mirror image, on the left side. So I'm going to have another point that's 1 space away on the left. So once you have 1 point, you can just duplicate it on the other side. You don't have to plug in. You could plug in another number if you wanted to, but you don't have to. So once we have our 3 points, then we can graph. So we just connect the 3 dots with a parabola. Our graph is a U-shape graph, not a V, so just make sure it has this curve to it. All right, so step 1 is to find the vertex and plot, and graph it. Step 2 would be to find the axis of symmetry. I'm going to call it AOS for axis of symmetry, and graph it. Step 3 is to pick a number close to the axis of symmetry to plug in So pick a number close to the axis of symmetry to plug into x and solve for y. And then that would be your point, x comma y, and then graph it. And then last step, step 4, would be to graph the mirror of it. The next slide just talks about how standard form is our a times x squared plus b times x plus c. We can go from standard form to vertex form, but it's not really helpful to go from vertex to standard. So most of the time it'll give you standard form and ask for vertex form. So this slide doesn't really mean much. So we're gonna go to the next one. So here we have properties of our graph. So if it gives it to us in standard form, we want to find the vertex and the axis of symmetry. So that's the third bullet point here. So to graph, we want to find the axis of symmetry and the vertex. It's also helpful to know that whatever our C is, that's the y-intercept. So that's where we cross the y-axis. And then also our A tells us the direction of our graph, if it opens up or if it opens down. So if A is positive, our graph opens up. It's a smiley face. If A is negative, our graph opens down and it would be a frowny face. So A just tells us the direction of our graph. If we look at the example we did on the last page, our A was -2, which explains why our graph opens down. All right, example 2, we're going to graph a quadratic function in standard form. So if it gives us standard form, we're going to do what we did on the first slides and find the vertex first. So our vertex formula is -b over 2a. That's how we find the h. What's my a here? 3. What's my b? -6, and c would be 1. So this would be -6 over 2 times 3. -6 makes it a positive 6, and 2 times 3 would be 6. What's 6 over 6? 1. So the h in my vertex is 1. How do I find the k? Plug in what? Plug in 1. So I plug in 1 into all the x's. So I have 3 times 1 squared minus 6 times 1 plus 1. So 3 times 1 squared. 1 squared is 1, and 3 times 1 is just 3. 6 times 1 would be 6 plus 1. 3 minus 6 is -3, and -3 plus 1. So -3 plus 1 would be -2. So So my vertex is 1, comma, negative 2. So I'm going to graph my vertex. I'm going to go to the right to positive 1 and down to negative 2. What's my axis of symmetry? Just 1. X equals 1. So my axis of symmetry is x equals 1. So I'm going to put a line right through my vertex. And when our function that's given to us is in standard form, we don't need to plug in to find another point. We can use our y-intercept as a point. So my graph crosses the y-axis at 1. Remember, it crosses at C. So my C is 1 here. So at the y, my graph is going to cross at C. So I can put a point at 1. So now I have 2 points on my graph, but I need 3 to graph it. Awesome. I have the same point on the other side. So since this point is 1 space away from my axis of symmetry here, I have the mirror image on the other side. So I'm going to have that same point on the right side of my graph. Once I have 3 points, I can graph. And then we're done. We know that it opens up because our A is positive. So when A is positive, it opens up. So we knew it was going to open up before we even graphed it because A was positive. And then step 4 would be to plot the y-intercept, which is C. So these are the steps to graph in standard form. The other one is the steps to graph in vertex form. And I forgot, once we plot the y-intercept, we also have to plot the mirror of it too. That way we have 3 points. All right, so here we have vertex form, so we can identify what our h and k is. So what's my vertex here? Awesome, -1, because we have to change the sign of h. And then we're not adding anything on the outside, so it'd be -1, comma, 0.
So you only change the sign when it's in vertex form?
Mm-hmm.
Because in standard form you didn't change.
No. So we only change the sign when it's in vertex form. So I'm going to graph my vertex. I go to the left to -1 and stay on 0. What's my axis of symmetry? X equals -1. All right, so for vertex form, how do I find another point? I only have 1 point, so I can't. I need a second point before I mirror it. How do I find a second point? I can plug in a number for x. What's a number that's close to my axis of symmetry that I can plug in? -2, but what's another number that's close to my axis of symmetry that might be easier to plug in? 0. 0's right next to my axis of symmetry, and it's going to be the less math to do. Plugging in 0 is nice because it's just 0. If you plug in -2, that works too. If you wanted to plug in 1, that works also. But I think 0 is the nicest one to plug in. So I have -3 times 0 plus 1 squared. Make sure you follow your order of operations. So I have to add inside my parentheses first. So this would be 1. Then I do the exponent. So 1 squared is what? 1. And -3 times 1? -3. So I plugged in 0 and got -3. So I'm going to stay at 0 and go down to -3. Put a point right there. Now, Joey, how can I find my other point? Mirror it. So since I'm 1 space away from my axis of symmetry on the right, my other point's going to be 1 space away on the left, and then I can just connect the dots with my parabola. from the beginning, I knew this graph was going to open down because my A is what gets multiplied out front, and my A is negative, so that tells me it's going to be a sad face. So let's look at number 3. So step 1 to graph when we have standard form is to find the vertex. So my vertex is negative b over 2a. What's my a? 1. What's b? And c? Negative 1. So this would be negative 2 over 2 times 1, which would be negative 2 over 2, which is what? Negative 1. So the first number in my vertex is negative 1. How do I find the second number in my vertex? How do I find the k? Plug it in. So this would be negative 1 squared, bless you, plus 2 times negative 1 minus 1. So negative 1 squared is 1. 2 times negative 1 would be negative 2 minus 1. So 1 minus 2 would be negative 1, and negative 1 minus 1 would be negative 2. So my k is negative 2. So I can graph that. I'm going to go to the left, negative 1, and down 2. What's my axis of symmetry? X is equal to negative 1. Don't forget the x is equal to. So we put a dotted line right through the vertex. And then what's my y-intercept? Negative 1. So my graph crosses the y-axis at negative 1. So I have a point right there at negative 1. So if my graph has a point at 0, negative 1, what's another point? I have to. Perfect. It would be negative 2, negative 1. Because if I go to the right 1 space, I'm also going to go to the left 1 space. And then I just connect my dots. And I knew from the beginning that my graph was going to open up because A is positive. So when A is positive, that means our graph is a smiley face. It opens up.